All right, well, thank you for coming. My name is Kate Sherwin. I'm the gifted coordinator for the Nebraska City Public Schools. And as I was just discussing, it was about 3 years ago, right before school started. I'm always looking for a curriculum. I don't get a big budget. And I found out about this workshop at UNO. And so I went and I liked it. I'm like, maybe I could do something with that. I have no experience with coding, no schooling with that. And so, but, you know, you're always trying to be brave and step out of your comfort zone. So I started using Bricklayer with my gifted students, trying to teach them coding. And then last year, I was given a high ability math class at the middle school for 6th graders. And they said, just do what you do, Kate. Come up with some curriculum that's multidisciplinary and make it good. And I'm like, do I get money? And they're like, of course not. Just go, be free. And so I decided, I need to use Bricklayer somehow. So we got to our geometry unit, which is kind of right before testing. We were all kind of, testing with all that. I needed to do something fun. So I thought, how can I use Bricklayer and connect it with geometry to make something fun, project-based, and doable for everyone, because not only gifted students were in this class. I had some kids who would score really high on the test. They were placed in the class, but really, there were big gaps. So I needed something for everyone. So hopefully you have a computer, one of your own, or one that I opened and took you to the page. So if you go to bricklayer.org, under the dissemination page, I opened, and you all have it opened already on another tab. I'm not used to Victor's computer up here. How do I keeps opening that when I click on the tab?
You should be able to click.
There we go. I have to be very gentle with it. So he made it look really nice. When I typed it up, because as a teacher, you need formative assessments, you need vocab, you need summative assessments. So it can't just be, a fun project. It needed to be something accessible. And so I came up with a little unit that starts relatively easy and gets more in depth. And it's available for you there on the Bricklayer webpage. You can print it out. So it starts out with just basic stuff. Coordinate plane, line segments, basic two-dimensional shapes, and then it goes into more transformations, symmetry. If you were in the last session, Bricklayer has a great symmetry app that's pretty cool that I need to get into and mess around with. And then finally it ended with some of the more trickier things, measurements. I was really losing them when we were doing the paper pencil. It was not fun, and I was losing them. So I needed something to spice it up. So I want you to get some hands-on experience with this, because when I attended Victor's workshop a couple years ago, going online and doing it myself was the only thing that made it click. You can walk away from a workshop saying, oh yeah, great, love that, I'm going to write it down and do it sometime, and then you never get to doing it. But if you feel comfortable yourself with it, you're more likely to do it with your students. So keep that tab open, the dissemination page, but go back to the Bricklayer homepage. Under apps, go ahead and go to the third one down, Bricklayer Lite. There are 3 different levels. You can mess around with them. Level 1 is a little bit easier, but there are limitations on what the students can build. I don't think I really messed around with level 2. I like level 3 because there's more colors. The kids want to pick their different colors, and you can really customize what you build. So go ahead and click on level 3. I'm going to walk you through that. I'm just hoping everything goes well. Being recorded. So the first thing, of course, I spent a couple days doing some code alongs so they were familiar with the program and how to use it, so they would feel confident, and so they would have something to look forward to. So the first thing you do, obviously, is open the level. So I want you to click Open Level, click Drag and Drop it onto your workspace. Now, this is getting them ready to learn SML, programming language. And at the end of each line, there's a semicolon, and that's the step my kids would always forget, so heads up. And I told them they can do this as they go, putting semicolons. Some of them, I can copy and paste them on all the lines, or you can do it as you go. Well, I'm going to do it as I go because I don't want to forget anything. So go to Symbols, click, drag, and drop a semicolon at the end. That line is completed. We've just opened a level. Now go to Build Base Plate. Like Legos, you need something to build on, and you get to determine how large that base plate is. So click, drag, and drop, Build 2D. Drop down menu, let's go to 32 by 32 just to be safe, give us some wiggle room. So you can copy and paste that semicolon, or you can go back to Symbols and get another one to finish that line. The program will not run if you forget a semicolon. So, because it's getting you ready for real programming. One little misstep, in the whole thing, you got to go back and search. So, along with teaching all this geometry, it was teaching my kids organization, a method, a strategy, being focused. So that was really good. I noticed those skills being taught along with it. So here's the first challenge that we're going to do together. And it's a relatively easy one. I say that, but I'm sure the first time you do it, it does not seem quite easy. And it's going to be congruence. So we were just two shapes that are the same. And so I might start by modeling this, but I think it's best if we try and fail and try again until we come up with the answer. So the challenge is to create a red square with two congruent rectangles, and I've specified the colors I want, blue and green, on the inside. And there's more. I want to make sure that you can see the outline of the red squares after you've placed those rectangles in there. So I also like to get my kids talking about math. Why did you choose to do it this way? What problems did you encounter? And everyone approached it differently. So rather than me showing you, we better do this first one together, I guess, so you know how to make squares and rectangles. So we'll do this one together, but there are different ways. When you think about it, if you already knew how to program, which one would you want to place first, the square or the rectangles? You have to have a square with two congruent rectangles inside and still be able to see the outline of the square. Any ideas which one you would want to place on the grid first? Okay, put the rectangles on there and then work around them to get the square. Okay, I'm inclined to want to put that big square, a big enough square where if I mess up, I can somehow manage to fit some rectangles in there. Because I know there's got to be that outline on the outside. So just because I like to do things easy, what I like to say is easy, we're going to do the square first. So go to Function Calls, click on Shapes. Put in line. So if you wanted to do line segments, you would use this block, but I want to do a 2D figure. So click, drag, and drop, put 2D. Before we forget, let's get a semicolon on the end of that. Nothing more frustrating. Now the first set of numbers is going to tell you the dimensions of your two-dimensional object. So if it's a square, I know that all four sides are equal. And so I want it big enough so I can have some wiggle room. So I'm going to do a 12 by 12. So go ahead and 12 by 12. This is where you set the color. And if you'll remember from the challenge, what color do I want my square? So, and the kids are like, can I do the dark red? Yes, I don't mind. So whichever color of red you want, go ahead and put it there. So this second coordinate is going to tell you where on the grid you're placing your 2D object. And it's important to know when you're placing your objects, you're not placing from the middle of the square. So think of the square, you're placing from the bottom left brick, if you will, cell. So wherever I'm going to place this, okay, I'm using this as I hold on to it, the bottom left cell, to move it around. I have to remember my base plate's 32 by 32, and I'm putting a 12 by 12 down. I don't want to put it right on the edge because I don't want to. So I want to go to 4 over 1 up. So it's not too far away, but yet it's not banging into the side. So let's go 4 over on the x-axis, 1 up on the y-axis. Now, if your kids wanted to check their programming so far, just, check as they go. If my gifted kids, they don't like making mistakes. So they really want to check and make sure that line is good before they add on to it. They need to build up some trust. I'm going to show you how to show your program. So go to Show, click Drag and Drop. I must say, I tell my kids never to mess with the thing in parentheses. A lot of them want to rename. This never shows up on the programming. They don't get to see it anywhere. And if you forget to keep the quotation marks around whatever you rename it, errors. So I just always say, if you're going to rename it, which I know they really want to for some reason, even though the name is not even going to show up, make sure you keep the quotation marks. But I recommend not messing with it. And of course, click, drag and drop a semicolon. Review, looks good. Everything's put together. I don't have any random buttons floating around on my stage. So I am going to go up here, top left, and click Run. I want to run the program I just created. Just so I can see, because I'm one of those gifted students, I want to make sure what I have is good before I add on to it. And if I like it, I like it. If I want to move it, now's the time before I add to it. So I'm happy with it. And it does help now that I see my square. I can visualize where now I'm going to place my rectangles. They have to be rectangles. So one side has to be longer than the other. And I have to make sure when I place them, I can still see the border. So you're already thinking, if I have 12 across and I need to see a border, what if I have a 1-cell border? Well, that's 1 subtracted from this side and 1 subtracted from this side. So the maximum width that I can make if I stack these rectangles one on top of the other would be 10. And that means I have 10 to work with on this side too. So if I wanted to place my rectangles horizontally stacked, it would have to be a what?
10 by 5.
Yes, it would. So already I'm using visualization, spatial orientation, moving things around in my mind, which is, I always think it's a given because I've always been good at it, but it is not, as you know. Some kids really cannot visualize those just because they haven't had that practice. And doesn't matter if you have a whole bucket of Legos, this is free and online, and any classroom can use it. So that's again why I like it. Like I said, I do not have a budget. Tell your husband, who he knows down there, get me a budget. So I'm going to disconnect my Show 2D thing because I know I'm going to have to go back in there, add some more Put 2Ds to create. Now, this is layered. If I put my square first in the programming, think of it like you're cutting out construction paper and pasting it. That's going to go down first. So if I were to have programmed my 2 rectangles first, that's fine if I want my square to show up because I'd make it bigger and it'd show up even if it was underneath it or on top of it. But if it were to be the same size with stuff in between that, so order does matter is what I'm saying with the programming. Order matters. So let's go back and get another put and line. Let's get a put 2D. Thinking ahead, I know I'm going to need 2 of them. And I like to be efficient, so I'm going to grab 2. I'm going to reconnect. I don't like to leave them hanging, so I'm just automatically going to get those semicolons in there. So now I put it together. If I remember from the challenge, what colors do my 2 rectangles need to be? Green and blue. So I like to mess with the color first. Any shade of green will do. Any shade of blue will do. Now, I think it's easier to mess with the dimensions of the rectangle before figuring out where on the grid I'm going to place them. So we talked about taking off 1 from every side to make that border, so the maximum width, if I'm stacking, is going to be 10. So I know I need a 10 by 5. And I know this other one is congruent. So it's also going to be 10 by 5. Now, if your kids are more advanced and they have knowledge of how to manipulate coordinates mathematically, they could look at that x coordinate for my square. We know bottom left is at over 4, up 1. So if I wanted to put my green rectangle at the bottom, I know I need to go over 1 more, so x plus 1, that'd be 5. And then I know I need to go up 1 more, so y plus 1, that'd be 2. So let's try 5, 2. If you're scared and you want to disconnect and run, you can go ahead and do that. Let's talk about this. I want them to be flush, one against the other. So here I'm doing some stuff in my head. I'm thinking, okay, so this green rectangle is over 5, up 2. So I know if it's up 2, that means the bottom left is at 5, 2, which means the one on top of it would be 5, 3, 4, 5, 6. And I have some kids who never really reach that point, and they use their fingers and they count. They go over any guesses as to where we should put our next rectangle. Or do you want to run the first one to see? Let's run the first one. Go ahead and bring down the show 2D. Disconnect from the bottom. Get rid of your other. Let's run that. It's a little easier to see. Remember, we're placing from the bottom left brick, not in the middle. So we're over 4, up 1, 2, 3, 4, 5, 6, 7. So over 4, up 7. And if they were comfortable, they could just add to the y coordinate because they know the y-axis controls the vertical movement. So if they're pleased, they can get another, the one they discarded to run, get it in there, make it congruent, the same width, same height, set the color, over 5, up 6, 7. Thank you. Here we go, run it, and see if they've satisfied the challenge, which they have. So that was the easiest of the challenges. I think it's really fun though, because after so many of these, oh, Mrs. Sherwin's coming up with the challenge and you're gonna solve it. Can I make my own challenge? Oh my gosh, yes. But you'll have to explain it like I explain them to you. So I had kids teaching others, reciprocal teaching. They were talking about, oh, I don't like how you made it sound like that in your challenge, because then I thought I had to do this. You need to be more clear with your expectations. So, I mean, they just like to run with it. And then they like to, with their challenges, instead of something boring like this shape, they wanted their peers to create something spectacular. So they were exceeding my expectations. I mean, I had created rubrics to go with these challenges. And I ended up having to scrap them and rewrite them because they were exceeding expectations so much, and I never had that type of a problem before. So that one's done. They can save if they'd like to. I always had them take a screenshot though, because it was a lot easier than writing down the URL that pops up when you save. Does it still work like that? So I always had, they know how to take screenshots. They do that all the time. And so I just had them take a screenshot, but I told them to make sure they include the coding block along with the image, and then they get to print them out. It was fun. We could display their work. So-and-so's challenge. We'd set up stations around the room, incorporate movement into the lesson. Who wants to go solve that one? Go over there. And it really frees you up as a teacher. You're able to circulate around. People are working at their own pace. You're able to really help kids who need it right then and there. So once you do the modeling and set the expectations and they know the routines that are in place, you can really rock with this. So I want to show you, what are we looking at for time? I wish we had more time, you guys. I could spend all day doing this. Something fun that's in the back of my mind. We just did, it was a really abstract unit. I need to refine it a little bit more, but about Fibonacci sequence. 1 + 1 is 2, 2 + 1 is 3. And so I would love to be able to, I did have him go on and do the golden rectangle, do all that. But I would like to do a little bit more with this. So that's what I'm working on, some Fibonacci going on with this. But you can code circles. So I'll show you how to code a circle because the next challenge has them doing circles with line segments marking radius and diameter. So if they like to visualize that stuff, they can. So let's go ahead and go back to our program we had. Let's get rid of all of our put 2Ds. Let's keep the rest. And go to shapes. So circles, they're going to be filled in. Rings are going to be empty. So you can really, I had kids programming the Olympic rings one day because it was last year, there was something going on. And so if you do circle, you set the radius so that automatically they know, oh, that's only going to be half of it. So I really need to set this thing away from the edge of my stage. So if you do a radius of 5, that means I have a diameter of 10. Whatever color you want to make it. I'm going to aim for the kind of middle, kind of. Connect, get a semicolon on there. So, and they can even see their programming actually how it would look if you scroll down. So if your kids are serious, if I had a group of them that were really serious, they're like, Miss Sherwin, I don't want to be using these buttons anymore. I want to actually type this out. And some of them were like, I'm scared to death of that. I never want to get away from the buttons. You can scroll down, and for the program you've run, it will show you in SML what that looks like. And you'll see how, this is why I like this block programming better than like a Scratch or something, because although Scratches block, it doesn't look and lay out like real coding does. And this does. The buttons you'll see up here, they look like what they do down here. They're very similar. So it's easier to jump, I think, using Bricklayer from a block-based coding system where you put together the blocks to actually typing out lines of code. It's an easier jump there. So some other challenges that I had, I'm going to look down here. Line segments, instead of a circle, you'd go to put in line, and you'd grab line XZ. You'd do the end point here, and these coordinates. The other end point, pick a color, and it's there. That was a lot of fun. Tessellations. Oh, and on the curriculum, I did include possible solutions. So if you didn't want to take the time to make your own teacher models, they're there for you. So it's all there for you, ready to use. And of course, you can come up with your own solutions. Like in this one, I chose to do the rectangles vertically. Go down here, here's some more of the solutions. Transformations were a lot of fun. We were studying Escher, and really trying to make that connection with art, because like the principal at the middle school said, you need to make it multidisciplinary. And so I was like, okay, we're going to do some coding and some art. And I really like Bricklayer has been really pushing the art a lot more. Our district finally got a 3D printer. It takes forever, but it is really fun for the kids to really work hard on something and then get to physically hold it. Makes for great conferences, open house. Really looks nice in the display cases with with their picture next to it and all the coding printed out beside it to show you what they did. So for each challenge, I have some questions that they can do think, pair, shares on in the middle of the lesson, or you can make it into some sort of a journaling activity after the lesson. You could even motivate them, come up with something better than mine so I can use it as the teacher model. They always liked that because they always wanted to be smarter, you know. A lot of the symmetry, dilation, scale factor is fun to do. And at this point, on these 2-point challenges, that's the second level, we were doing a lot more of the math along with the visualization. And I thought that was a good part to do it, to start doing it at, because you were like multiplying or adding, and it just seemed to just flow well. Maybe it was that group of kids. We haven't gotten to this unit yet for this year, so I'm anxious to see kind of doing the same thing with a different group of kids, what I find, if it's similar or different in some ways. Here's a scale factor 1. Now, stage 3 was the most difficult because they're actually using formulas, midpoint, distance, and these are 6th graders, not all gifted in math, just recommended by their 5th grade teachers, like they could hang, they could do it. And the formulas looked really intimidating to them, but they were motivated, number 1, to see their work, to actually get to do it, not paper pencil, but online, and then trial and error. There must be something wrong with your math if your screen does not look right. So it was really nice, because if you're doing it paper pencil and they do the formula wrong, they put it on the paper wrong. So you can really start to see the errors more when the computer is doing it right away. It takes out some human error, really shows you. We were doing parallel lines, perpendicular lines, slope, area, perimeter. So if you scroll all the way down, here are my actual lesson plans. I lined them up with some technology standards, which I need to update, see if they've changed. I think I heard from someone they were updated, and some Nebraska mathematics standards. So the kids were doing high school level math when we got to stage 3 with the formulas, but they didn't quite mind, and they really weren't aware of it. And now they come back when I see them in the mornings, they're like, we're doing the same thing we were doing last year with you now, and we know. And I'm like, did you tell your teacher to use Bricklayer? They don't know how. And I'm like, well, I need to talk to them. So that's part of the reason why I really wanted you to do some hands-on, because it'll look intimidating, but when you get into it, and it's okay to make mistakes. There were so many times that I totally goofed it up, and I was so nervous about goofing it up in front of them, and they were like, it's okay, Mrs. Sherwin, this is what you did. And I'm like, come up here and tell the class what we do, play it off like I did it on purpose. So it's really fun to be able to learn together. I think those experiences are a lot more rewarding. So we really had some fun. We got into some really great conversations. We were starting with the Fibonacci sequence. We were starting to go into fractals, repeating patterns and all of that. And that was we were doing stuff I don't think even exists in the K through 12 curriculum. And I remember at the workshop that I went to, the very first time I was introduced to Bricklayer, I remember Victor saying, the reason why I did this is because I get so many college freshmen coming in wanting to do computer programming, not knowing even this foundational stuff. And as a teacher, I hear all the time, we're preparing kids for jobs that we don't even know exist yet. And even if we don't feel comfortable with it ourselves, we're teachers, we're not computer programmers maybe, we can at least, make the effort to think outside the box, to use something at no cost, very, very, it's not hard at all, and do something with it. So hopefully, no matter what they decide to do, they at least have something that they feel confident doing. So maybe in a couple of years, they'll make an appearance here at UNO and be able to do well in at least maybe the first couple months of your class, who knows. But down at the bottom of the curriculum at the end, and this is on the dissemination page ready to print out, I've included some formative assessments, not all of them, just the few that would fit on the page. and some summative assessments. So I know how frustrating it is to be learning something and then trying to fit it into everything you need to. Like, I need this grade at this time. I needed this grade. I need engagement. They're coming around, gonna check to see how engaged the kids are during the 15 minutes that they're in my room. So, I mean, if you're doing this, you're gonna have talking, you're gonna have problem solving, you're gonna have project-based, problem-based learning, you're going to have engagement. They're going to be just do it at the end of the year, because everything I did after this was not as exciting. So I need to come up with something to follow this that's not a complete embarrassment for them. Scrolling up to see what else. I do want to show you the other levels, though, in case your kids are not ready for this level 3. I think I have 2 minutes. Up here on your screen, go back to Bricklayer Lite right quick. I want to show you the difference really quickly. With my younger kids, and I didn't just do this with 6th graders, I actually really reached, and I did it with some 3rd graders, but we had to go very slow. They had to have knowledge of the coordinate plane first, so we did some coordinate plane battleship and things like that to really get into it. And then I said, and you're going to be 3D printing, and then yes, and they were on board, and it was awesome. So in level 1, it works the same. You can open the level, build your base plate, but the function calls are different. You can't customize, I think, as easily as you can in level 3. And the one thing I do, there's not as many colors. And for the younger kids, well, and the older kids, they like to be able to show what they want to show on that screen. They do not want to have limitations. So this is a good place to kind of start, but if you're going to do the geometry challenges, level 3 is where it's at. So you can put yellow and see how they're filled in for you. The length and the width, 1 by 1, it's there. But there's like no 1 by 3. So these are but then again, you could say, you could make it challenging. I want you using these to make this, and there's no button for it, so they're going to have to overlap a couple of shapes and make it their own. So if you wanted a 1 by 3, you could do a 1 by 1 here, and then scooch another, 2 by 1 or up on top, and just overlap. So if we mess around with this, and the same thing, we got a show. The bottom, just put in some coordinates right quick. These are the colors that you have to choose from, so a wide range of colors in level 3, but very, very similar. So this could be a good spot for you and your kids to start. Mess around with it. But the possibilities are really endless. There's always things that I'm thinking of, what else can I do with this? How else can I make it work for me? So please print that curriculum out, make it your own. If you want to contact me, I don't know. Is my email on there anywhere? I'd like to give it to you in case you have any questions.
On the program?
Yeah, I don't think it is. Probably not, because I don't think we put our emails on programs. But I'll give it to you. It's my first initial K, last name Sherwin, at N for Nebraska, EBCITY, so Neb City, PS for public school, .org. K Sherwin at nebcityps.org. And if you want to collaborate, you can Skype each other's classrooms. Mm-hmm. That would be fun. That'd be a lot of fun. My kids need some diversity. So thank you guys for coming. Thanks for being good sports, coding along. If you didn't make it to Victor's last session, that was way better. It was way cooler with the symmetry. Shouldn't follow that ever again. No.